Hello, and welcome to 5 Minute Math. Today we are looking at lessons learned from the sixth grade STAAR test 2025. Specifically, we are going to look at the readiness standards in which overall the state scored less than 60% mastery. And we will start with our lowest scoring readiness standard first. That is 6.8D. So this was tested just once, as you can see here. It is a new item type, but it's not multiple points. It's only just 1 point. We only had 25% of our students able to get this correct. Now, what we needed to do is we needed to find the area of each of these figures and then find two that have the same. So we had to apply area of a trapezoid. So that's 1/2 base 1 plus base 2 times height, or sometimes what they'll do is they'll just put all of that over 2. And then we had to find the area of a rectangle or a parallelogram, and that's just going to be base times height. And then triangle, 1/2 base times height. We had to apply all of these, which is a lot of calculation. And a lot of times what students do is they'll kind of get tired and start eyeballing things. So if we look at this trapezoid, base 1 and base 2 is 16. Take half of that is 8 times 7 is 56. This is going to be 52. That's 4 times 13. 12 times 7, we can either do that or we can go ahead and take half of the 12 before we do that. So let's go and do that. That's going to be 42. If not, it would have been 84. Then we would have had to take half on the back end. 21 times 21 is going to be a whole lot. I'm going to not even calculate that because look, that's over. That's greater than 400. I know 20 times 20 is 400. So that's just one that's not going to be used. Now I need to find this one, and the problem is we're not going to use that 8 centimeters. That's the slant height. Height of a parallelogram needs to be perpendicular, so it's going to look like you have inside of a triangle. It's going to have this dotted line with a little square. So that's 7 times 6, that's 42. And so here are our two answers, right? That triangle and then the parallelogram. Those two are both 42 square centimeters, and only 25% of our students got it correct. Why was this so difficult? Well, we had to apply all of these trapezoids, rectangles, squares, if they chose to do that 21 times 21, triangles, and parallelograms. It's like every single shape we know how to find the area of, all in this exact same problem. And what ends up happening is we'll just try to eyeball it. We'll just use some spatial reasoning, and rather than applying the formula, we'll say, well, those look the same, or those numbers are similar, right? So if I'm just looking at numbers, I see, I see a 7 and a 12, but I don't see a 7 and a 12 there. I see a 7 and a 12 here, right? So I might be thinking, okay, 7 and 12, 7 and 12. So they might think it might be these two because it's a 7 times 12, but a triangle and a trapezoid are calculated completely different ways. So this white font is going to show us some instructional implications. What can we do as teachers to better help our students with 6.8B when we're determining solutions for problems involving area? Well, we know that the area for parallelogram, square, and rectangle, right? We need to just find all three of these, parallelogram, square, rectangle, base times height. Very simple. And then the triangle is half of that because you could take any of these, whether it be a parallelogram like this, right? You can take a square, obviously, a rectangle like this, and you can simply cut it in half to get two equal triangles. And so that is an easy way for us to remember that the triangle is 1/2 the base times height because a triangle is half the side of a parallelogram. The trapezoid is a little bit more cumbersome there. It's more nuanced, and they should be, rather than trying to remember that, they should be comfortable using that with the reference materials that are available on the STAAR. But what they should be able to do is see it like this. Sometimes we'll see it over half times height, or like I showed it to you, the 1/2, right? Obviously, in sixth grade, we spent a lot of time noticing that multiplying by 1/2 is the same as dividing over 2, and I can divide by 2 by making it look like a fraction. But we should be comfortable with it in either of these formats. Our next lowest was 28%. This is 6.70. We are generating equivalent expressions with all kinds of properties. Inverse, identity, commutative, associative, distributive. All right, so we need to find two that are equivalent here. And even though it's a drag and drop, it's only 1 point. You either got the two or you did not. And so this one is actually the identity property because anything times 1 is itself. So this is just 7 times x or 7x, right? And this is just showing one way to show division is you can make it a fraction, which as we can see, that's going to match this right here. This is the distributive property. So we need to multiply that x by the 7. And really what we end up doing is we end up flipping it around so the number goes first. And then the x times the 1. 1x, we just drop the 1. It looks like that. And then we've got this x over 7 and then 7 over x. And so these two aren't the same. And what we did is we matched this one right here. So it's 7 divided by x plus 1, and then 7 over x, which is really the same as 7 divided by x. And that's something we focus on in 6th grade. You can do those in either box. If you were to flip those, you would also get that correct, but only 28% of our students were able to get that. So even though we needed to know the distributive property, and a lot of times we boil this down to the distributive property, this is just one property. And you notice how they folded in the various ways to show division, right? So that's really what this problem was about. It could have been dual classified with 6.7D and 6.2E. We needed to know the various ways to show division to make sense of this problem and to know that we're not going to use the distributive property unless there were parentheses. So that's where the distributive property came in. We wanted students to know that we use the distributive property here if there's anything left, right? It's just you have to multiply the x times 1, but there's nothing left after that. You only use the distributive property here because there's a plus on the inside, but you don't use the distributive property there because there's no parentheses. And so sometimes it's as important for students to know when to use the distributive property as when not to use the distributive property. And these properties are huge. Being able to mentally change these are the foundation for algebraic thinking moving forward. So if they don't have this, they're going to struggle as the problems, the equations, the inequalities get more and more algebraic and they get stacked inside of, different properties. They're going to be more and more difficult for our students if they don't have the grasp of this. So this is a very, very important readiness standard. So what does that mean for us in our instructional implications? Well, you can't spend enough time with the distributive property. Not only going to the distributive property, right? So A, this is how they normally show it, right? You distribute out the A and both the B and the C, but we also want them to be able to factor out, right? We want them to be able to go from this to B plus C. Obviously, that adding is going to be important. That's a key feature of the distributive property. But going from this to this, factoring out the distributive property, we call the inverse factoring out. That's going to be super important as well. We can use the area models to graphically represent the distributive property, right? If we wanted to show something like 8 times 7, right? We could do something like this, and we can just make it 4 and 4, and we can show that 8 times 7 is the same as 4 times 7 plus 4 times 7, right? 28. 28 makes your 56. And we really need to kind of move away from using this division symbol. And moving forward, 28 divided by 7 is going to look a lot more like that. Then it's going to look like this. And really, we'll only use long division if we actually have to do the calculation by hand. But this is going to be our primary notation. So our students need to be very, very comfortable with seeing a division problem or seeing just a fraction and thinking, oh, this is probably a division problem. 6.5b is next. We had 31% overall mastery, solving real-world problems, given the whole, a part in a percent, finding the whole, or finding the part given a whole in percent, so on and so forth. Okay, so we have an employee starting salary at 36,000, 3% increase. Well, we need to find 3% of 36,000. All right, there's a few ways we can do that. One, we can do a multiplication problem. When we take a percent of something, that means we're going to multiply. And we need to change our 3% into a decimal, so we can either make it 300ths because it's 3 per 100, or I could just move the decimal over twice. But I could just multiply these two. 0, 0, 0, 18, 10, 2 digits behind the decimal, 2 digits behind the decimal, 1,080. That's it. I'm just wanting to find the salaries increase. That's it right here. Or one way is we could find 1% of 36,000. All right, so if I take 10%, I'm moving the decimal over once. Right, 10% is 3,600 because you're just dividing by 10, or taking 1/10. If I take another decimal, that's 1%. So 360 equals 1%. Now you might be thinking, how does that help me? I don't want 1%. Well, if I multiply that by 3, I'm going to get 3%. So if I multiply this by 3, you're going to end up getting the same thing, 1080. So sometimes you could do it that way as well. All we're looking for is 1080 or 1080. Now, more students, though, instead chose B, 34%. So we had 34% choose that and 31% choose the correct answer. How did we get B? Well, they just saw this 36,003 and they just divided. 36,000 divided by 3. And those numbers do go together. Mentally, I can do it 12,000. But holy cow, if they got a $12,000 increase, right? That's a third. 12,000 times 3 gets you 36. So really, you didn't find 3%, you found 33 and a third percent. So dividing by 3 is not the same as multiplying by 0.03 or 3%. Those are not the same. They both involve the number 3, but they're not the same. That was the challenge for students. And then when we had 14 and 20% here, that just lets me know that for the most part, we were pretty confused. Students had a little bit of thought going into B and C, but other than that, that was pretty difficult for students all the way across. They weren't sure how to approach this problem, and they were given the whole, right? And they were given a percent, and they needed to find the part. What was that part? So we need to emphasize our instructional implication that we can change the 3% into a decimal, right? Finding 3% of something would be the same as multiplying by 0.03. And this was a quote unquote easy problem. This easy could have been a second step. If they wanted students to find the new salary, they could have said, okay, find the increase. What's the new salary? And then they would have had to do the 36,000 added to the new increase, right? And then they could have done this as our new answer. So this easily could have been more difficult, but this was already, right, the third most challenging readiness standard on the test. So our students need a little bit more practice with the percent of something, knowing that means you're multiplying by a decimal. Next, 6.8a, also 31% overall mastery, knowledge of triangles. We just need to know how many degrees are in a triangle. And if our students get stuck, because there's a lot of numbers to memorize, this is what I suggest. Draw a square. Note the angles in a square. All right, most of us know we've got 4 right angles, so that's 90 times 4, that's 360 degrees, right? So if you take a square and find all the internal angles, that's 360. If you take that square, cut it in half, you're going to get 2 equal triangles. And so that means you're going to take your 360, cut it in half, 180, 180. So I need a set of angles that equal 180 because every single triangle makes 180 degrees internally. And the only one that does that is D. Now, that's this breakout here, including the sum of angles in a triangle. For this particular standard, they also need to know the relationship between the length of sides and the measures of angle, right? So this is going to be your largest angle is always across from your longest side. They need to know that. And then your smallest angle is always across from your shortest side. So they need time exploring that large angles are across from long sides, small angles are across from short sides. And then they need to know the triangle inequality theorem. What does it take for three side lengths to be uh, actually make a triangle, right? They need to know that your two side lengths added together always have to be greater than your third side. So A and B need to be greater than C, B and C need to be greater than A, and then A and C need to be greater than B. Only when, if you take those three inequalities here, add up the two sides, make sure they're longer than the third for all three sets, that's when it's a triangle. So this is a pretty packed reporting category, or pretty packed readiness standard. And our students got probably what was one of the easiest ones, was just 180 degrees in a triangle. And we struggle with that. Only 31% of our students got that correct. 25 chose C, 20 chose B. So 25% chose C. There we go. I knew I got that wrong. And then 20% chose B. Well, these are what makes C so interesting. Well, there are three equal angles. So they might have thought this was an equilateral triangle, but if you have an equilateral triangle, it's tough to make 180. So that's going to be 60 plus 60 plus 60. But they might have thought three equal triangles is what it takes, or three equal angles is what it takes to make a triangle. And that is obviously incorrect. And then 90, 90, 180, this actually makes 360. So maybe they were thinking of that square and they weren't cutting it in half, and they were thinking, okay, that's a 360 sounds important. And so they thought that was it. So this was definitely challenging. And the lack of answer distribution just really makes me think that students overall struggle with that triangle sum theorem. The fact that all three angles in a triangle internally equal 180, that they just didn't know that, because that's more of a recognition problem. There's a little bit of addition they need to do, but basically we're just recognizing, because obviously, none of the other answers equaled 180. They couldn't. All right, so how do we help our students solve this? Well, we don't have them memorize stuff. We conceptually show them. So what I showed you, a rectangle or a square, right? Four right angles equals 360. Cut it in half. That makes two triangles of 180 each. Let them play with that. Let them get out a piece of paper, cut out a shape that was drawn for them, a square, a rectangle. Have them get the protractor, measure the angles, and then practice drawing triangles and just adding them up. And so let them see that no matter how much they draw triangles, as long as the sides are straight and they connect, they'll equal 180 degrees on the inside. And the reason we want them to play with this like this is because that conceptual understanding lasts a lot longer than the memorization of random facts. 180 is not necessarily intuitive. So I know that because I've played with a lot of triangles and I've realized that I can not make a triangle that does not have 180 degrees on the inside. But I've tried and I played around with it, and acute, obtuse, scalene, right, isosceles doesn't matter. They need to play with it. They need to explore it, then they'll understand it. Next, we have 6.12D. We had 42% overall mastery. We have a percent bar graph. And so we need to not only just, first calculate the percent bar graph, then we need to evaluate each of these statements. All right, so I'm going to put numbers next to each of these on my key. So this dark black here, 5 a.m., is 0 to 10. So that's going to be just 10, and that's pretty easy. But that's the last one that's easy. This is where a lot of students struggle because a percent bar graph is new for sixth grade. They haven't seen it before. And so if it's not used to it, they might miscalculate. Take a look at this 6 a.m., this dark gray. It goes from 10 to 55. So I need to subtract those two. 55 minus 10 it's 45. But if I look at where it ends at 55, and that's the confusion. We have to know it's 45, even though it ends at 55. So now I've got a 55 to 80, so I need to subtract those. 80 minus 55, right? That's going to be 25. And then I've got 80 to 100. Okay, that's 20. So what I need to know here is I need to know that we are going to add all of these up and get 100. And if I can do that, then I know I've got my percent bar graph ready to go. So now I've got numbers on there, just like we always label a regular bar graph. Let's put numbers on a percent bar graph. Now we need to evaluate each of these statements. More than half the students attended the 5 p.m. Okay, so what would half be? So half is going to be 50. So they think my 5 p.m., which is 25, is greater than half, 50. That does not make sense. Now you see where the trick is here. The trick is 5 p.m. ends at 80. So if you do think the 5 p.m. is 80, 80 is greater than 50. But you can't, but the 5 p.m. doesn't start at 0, so you can't go from 0 to 80. You have to go from 55 to 80. So that's incorrect. Fewer students attended a morning session, AM. Okay, so that's 10 plus 45. That's fewer than afternoon session. What is it? 25 and 10, 20. All right, so that ends up being 55 is less than 45. Nope, doesn't work. But you see why I turned those into inequalities and I evaluated them algebraically. Fewer students attended the 6 p.m. session. Okay, 6 p.m. is 20. That is fewer than the 5 p.m. What is my 5 p.m.? That's 25. All right, you know what? 20 does look like less than 25. Okay, so let's hold on that. Check D. More than twice as many students attended 6 a.m. as attended 5 p.m. Okay, so what's my 6 p.m.? My 6 p.m. is 45, and that is more than twice than my 5 p.m. And what is my 5 p.m.? I'm going to do 2 times. My 5 p.m. is 25. So 45 is greater than 2 times 25 is 50. That does not work. All right, so my answer is C. Now you can see why we struggle with this. We had 42% of our students get this correct. That was a lot of calculation, and all of it depended on first putting the right numbers here and then using those. All right, it potentially requires 4 times as much work as any other problem because each answer must be interpreted individually. And when students see a problem that requires that much work, much like earlier when they had to calculate all of that area of all the different shapes, sometimes they just tap out and say, I'm just going to eyeball this. And then 40% chose D. All right, so 40% chose D, which is almost as much as chose the correct answer of 42%, right? And that was confusing because more than twice as many students chose 6 a.m. So there's a few ways students might have gotten this wrong. They might have just they didn't know what to do with this twice. And if you just take that twice out of there, 45 is greater than 25. If you just evaluate the 6 a.m. against the 5 p.m., it does make sense. Or they could have misinterpreted and put the twice with the 45, and then twice 45 is still definitely greater than 25. You had to know that that twice has to go on the 5 p.m., which is the 25. And so they need practice with statements like that and knowing how to turn that into an inequality. That's something that I have to slow down and make sure I'm doing it right because if you put that twice on the wrong side, obviously it's going to change everything. So first, what do we want our students to do? Well, we need to do as much work on a percent bar graph as we do with a regular bar graph where we're always wanting students to label all of the bars first. They need to correctly find the value for each section and then check that the sum is 100%. Once you've done that, now you're ready to Try to write an inequality or an equation for each statement and then check to see whether it's true or not. That's how we solve these. We don't just eyeball it. We put numbers on everything. We try to generate statements, but they need practice with that. Next, we're looking at 6.10a, 46% overall mastery. And we're just modeling and solving one variable, one-step equations and inequalities. And so we've got avocados. What do we have? We've got avocados. They are 65 cents each. And we want to find how many avocados can I buy? N. So I need to first recognize that this is my rate. And since it's for one, we'll call it a unit rate. And so I want to take that unit rate and I'm going to multiply it by as many as it takes for me to reach $10. All right, so first off, I should be able to eliminate these two. Not every student did. We need to recognize that the cost goes with the rate. When we're purchasing things, right? And typically, this is a pretty standard setup. They give you the cost of something and they're asking, how much can you buy? How many of these items can you buy for this amount of money? So we could have eliminated B and D. Now I just need to figure out which way does my inequality go. Well, if I have $10, then I can't spend 12, I can't spend 20, I can't spend 100. So that's my maximum. So if that's your maximum, then what I'm purchasing needs to be less than that. And so we need to show that less than or equal to symbol, we can equal $10. We can't go over $10. So obviously we want the opening to go to the larger number, and that $10, that's our tops, that's our max. Right? So our answer here is going to be C. And they didn't necessarily need to struggle so much with whether we choose, the less than, greater than, less than or equal to, greater than or equal to, because every single item was either less than or equal to, or greater than or equal to. And sometimes that's the question. Is it less than, or is it less than or equal to? Or is it greater than, or is it greater than or equal to? And then you have to use clues from the word problem to figure out, am I including that equal to? Every single one of these included the equal to, so that was not the challenge. 17 to 20% were our three incorrect answers, which means there was quite a bit of guessing, right? And so we had to first identify the unit rate and then interpret the inequality as that less than or equal to. And so that's how we need to have our students approach this, okay? 2 steps. First, let's identify the unit rate and where that variable goes. And most of the time it's going to be with the number of items we're buying. Sometimes it's going to be you know, the maximum amount you can spend, right? N would be, it could be something like 0.65 and I can buy 8. It's going to have to be, less than something, right? Um, but a lot of times it's going to be more like this, having that unit rate right there. So we identify the unit rate, step one, and then step two is interpreting the inequality. Which way is it going? Greater than, less than, and then is it greater than or equal to, or less than or equal to? And then how do we make sure that we provide our students adequate opportunity? Let's let them verbalize. Have them go back to this and just speak with a partner, right? Make it a group activity, make it a partner activity. Maybe even write something down if you want to practice those short constructed responses. Why is this correct? Interpret this and tell me why it's correct in the context of the problem. Tell me why this one is incorrect. What's wrong with that inequality? And have them put it into words. That will give them an opportunity to really make sure that they're understanding conceptually what it means to have $10. 6.3e, we only had 49.5% of our students get this correct. We are multiplying and dividing positive rational numbers, which means we're going to make it challenging. Number 12 was not that much of a challenge. We're just doing 178 times 5 cents. We have 178 nickels, right? And we just need to just multiply 35, 39. It's 8. I need to make sure I put 2 digits behind the decimal. 890. 64% correct. That wasn't a challenge. This one was number 20. So one of the things we work on really frequently in 6th grade is knowing that when you multiply by a number, it's the same as, or when you divide by a number, it's the same as multiplying by the reciprocal. So I can take my 8/18ths, and instead of dividing by 6/12, I'm going to multiply, then I'm going to flip it upside down. That's the reciprocal, 12, 6. Now, if I want to, that's a whole lot of multiplication, right? Those are going to give me some really big numbers and I have to do a lot of simplification. I'm going to go ahead and simplify. There's two ways to simplify. First off, I can simplify 8/18ths all by itself. I can divide both by 2. Now I'm going to get 4/9. And then 12/6, right? 6 goes into 12 twice. That's just times 2. I can make it a big 2, or if I want to keep it at fraction multiplication, I can make it 2/1. That makes that pretty easy. Or something that we'll do uh, later on is you can always, if you can't simplify within the fraction, you can simplify since you're multiplying diagonally, right? And so 6 goes into 12 and 18. 6 goes into 12 twice and goes into 18 three times. 2 goes into 6 three times and into 8 four times, right? And what you get is 4 times 2 times 3 over 3 times 3, which still gets you that 8/9. So when you're multiplying fractions, you can simplify normally within the fraction or diagonally. Either way, you're going to get that 8/9, and so your answer is D. And so it was fairly simple for number 12, though 18% did choose C. So let's look at that. And instead of multiplying, they just did 178 divided by 5. And they might have thought that's the same as multiplying by 0.05, but dividing by 5, right? 1/5 is 0.2, not 0.05. So that's where that came from, and we had a big chunk of students choose that. Obviously, we're needing to bring in 6.3a, seeing that dividing by a fraction is the same as multiplying by the reciprocal, right? And vice versa. So that's the skill we really needed there. And then 30% chose A. So 30% chose A and 35. So they knew something had to happen. How do you get A? Well, what they did is they did 8/12. Oh, let's hold on. Let's make that 30% goes right here. They did the 8/18ths. They changed it to multiplication, but they didn't flip it. They kept it as 6/12. And if you multiply 8/18ths and 6/12, you're going to get 2/9. So they knew something had to change, but they didn't know that you had to find the reciprocal as well. So that was definitely a challenge for our students. So dividing, by a fraction requires more steps than multiplying by a decimal, right? So obviously the first problem was just as long as you recognize it as a multiplying by a decimal, pretty simple. Dividing by a fraction requires you change the sign and then you flip and find the inverse or the reciprocal of whatever number you're dividing by. And that cross cancellation or basic simplification could have made that large fraction simplified a lot easier. Because what we don't need is we don't need students trying to do this and then simplify. Because what does it turn into? This turns into 96 over 108. I mean, that you can divide by 12s, right? If you know your 12s, and you're still going to get 8/9, but that's inviting a lot of calculation errors. Let's help our kids when they see numbers that big. Their first question is, "Ooh, can I simplify either within the fraction or can I do cross cancellation? Will either of those work?" 6.2D, this one is actually tested twice. Our first readiness standard that is low, that is actually tested twice. We're ordering numbers here. And in number 33, we didn't struggle too much. It's your very typical, here's my numbers, let's put them in a list. In this case, least greatest. And so if I take my numbers here, I'm going to put them on a number line. You notice I've got some negatives. So I know that those two negatives are going to go over on the left side. And I know that these three right here are going to be positive. And even before I do much work, take a look. I've got 0.0.1 point. All right, so I know that this 1.02 is going to be my largest, and all of them have that as largest, so that doesn't help me. Now I need the 0.3 and the 0.18. Well, they're only going to work if I make them both to the hundredths place. So 18 hundredths is smaller than 30 hundredths, so I'll put my 0.3 right there. So I'm looking for these two right here. Those two work, those two don't. So then my question is, what do I do with my negatives? All right, so negative 1/4, let's make that negative 0.25. Then I've got my negative 0.86. Remember, the larger the negative, the farther away it is from zero, right? Think of it like absolute value. And so my negative 1/4 is going to be closer to zero. And then my negative 0.86 is going to be farther away from zero, which means farther away from zero is the smaller number. And so I'm needing A right here. 56% of our students chose that. Now, this is the same thing. I still need them in order, but it doesn't tell me which one it is. Now, since we've got the inequality going this way, negative 2.6 is less than, so this is still going from least to greatest. But we need our students to have opportunities to use this inequality notation because you're going to see this a lot more than this, just a simple list. All right, so we need to find a number that goes between, and I've got decimals and fractions, okay? So let's uh, look at this right here. I would change this 12/7 to a fraction or to a decimal, but then sevenths doesn't divide very easily, right? That's going to be a number that's just going to go on forever and ever and ever. So let's look at the negative first, okay? I want to take a look at this, and let's just make this a mixed number. 2 goes into 9 4 times. This is negative 4.5 or negative 4.5. Well, that's going to go on the outside, so that is not included there, which means I need a number that is, there's no negative number, so I need a number that's between 0 and 0.1. So that's what I'm looking at, between 0 and 0.1, and I've got that right here, 0.025, because 0.1 is 0.100. So what's less than 0.100? 0.25. So that has to go right there. Now I need something between 0.100, and this is 12/7. So this is going to be 1 and 5/7. Let's think about where we think this one goes. 1 and 9/10. So they're both 1. And 5/7 is not going to be as big as 9/10. You could do, you could do comparison there by changing them to the same denominator, or you can just reason and say, well, 9 is only 1 away from 10, 5 is 2 away from 7. And so sevenths are larger than tenths, and so missing 2/7 is definitely going to be smaller than missing 1/9, which means that goes on the outside, which means my only option here is 1/8. And that does make sense. Tenths are smaller than eighths because that same whole is broken up into 10 pieces rather than 8 pieces. So each of those 10 pieces is smaller, which means your 8 pieces are going to be slightly larger. We did this in third grade. In third grade, guys, we would evaluate two fractions with either the same denominator or the same numerator. So we didn't need a whole lot of calculation there. Only 29% of our students got full credit, 32 partial, 40% no credit. And on the partial credit, we don't know which one they got correct, which one they got incorrect. So that number 11, use this inequality notation. It does mimic a number line, but it might have messed some students up. They need to know that if they're going like this, right, that's least to greatest. If you don't know this, then you're just guessing. So we've got to expose them to that so that they know that it's least to greatest. And we had to navigate, as you would expect in sixth grade, fractions and decimals, positive and negative. They need to be able to know, especially with those negatives, the larger the negative, the farther away from zero. Number 33 was the one on the left that was much more traditional, multiple choice, much higher success rate. All right, so what do we need to do? Well, we need to utilize the inequality format going in both directions. So sometimes it might be this. So they might go greatest to least. So we need to use this notation in both directions. And exactly like they did, positive and negative numbers, fractions and decimals, make them really close. And so that is going to give our students enough challenging opportunities for them to be successful. 6.12c is next. That's our reporting category 4. We got slightly over 51%. We're summarizing numeric data. Now, we need to find in number 13, which was the much more challenging one, mean and the median. So we first off need to know the difference between these two. What is the mean? So the mean is the average. So I will do this in this reddish pink. That means we need to take all of our numbers, right? And then we need to add them up. And then we're going to divide by the number of numbers that we have. So let's just add up, first off, quite a bit of calculation, even if we know what it is. So if we add up our numbers here, we're going to add up 15.1, right? 13.8, and then so on. We're going to add up all of those. Now I'm just going to do these on a calculator here. 15.1 plus 13.8 plus 12.9 plus 14.3. Students don't have the calculator. They've got to obviously just do it themselves. So that's going to be a challenge. But this ends up being 86.4. Then we've got to take that, we've got to divide that by 1, 2, 3, 4, 5, 6. All right, so that requires a lot of work. And if we divide that by 6, we're going to get 14.4. Now this is a measure of center. So that means the middle of this data set is around 14.4. But so is median. Median is a lot easier, but you have to put them in order. So let's put them in order. 12.9. I want to mark them off. 13.8. And then I've got a 14.3. And then two 15.1s. And then a 15.2. Now, if it is an even number, right, your middle is going to be between right there. So there's 3 on one side, 3 on the other side. You need to find the mean. So use that word mean again. I need to find the mean of those two. So I would add 14.3, 15.1. That's going to be 29.4. Then you need to divide that by 2. Or you can say 14.3 and 15.1 are 0.8 away. So what's half of 0.8 is going to be 0.4. You can find the distance between those two and then cut it in half. So that's going to be 14.7. So you can either divide 29.4 by 2, or you can just take the distance between those two, cut it in half, and then add it to the smaller number. So 14.7. So their mean and median are going to be very close. Every once in a while they'll be identical. Number 19 was a lot easier. Now the challenge was they didn't give it to you in order. Okay, we need to find the range. Range is the difference between the smallest and the greatest, but they don't give it to you in order. So we need to rewrite these, make sure we're getting all of them. 10, 12, 14, 16, and then 20, and then 24, and then I see a 26, and then 34 and 42. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this is a little bit easier because I've got 1, 2, 3, 4 on this side. 1, 2, 3, 4 on this side, which means I actually have a middle number if I was looking for the median. We can also use the mean if we want to, but in this case, since we've lined them up, we're just looking for the range. You notice that this one is an incorrect answer. We might have done all of this work and got it incorrect because we chose the wrong thing. We simply need to find the greatest and the least and subtract. Those are going to be 32, but the median is possible if you want that. So our answer here is B, and we got a lot more students getting that correct. 60% of our students were able to get that. The challenge was number 13. And so there are two different measures of center that included decimals, and obviously the mean takes a lot of calculation. And so that is one in which we need to be able to provide our students lots of opportunity. And when we're finding the median and we have an even number of data, and we need to find the average of those two middle numbers. Don't say average, say mean. So they get the practice of that. You take your two numbers, add them up, and divide by 2. In this case, the mean is you take all 6 numbers, add them up, and divide by 6. But they're very close. They're two measures of center. And this simple calculation 19 is range, but the data set was not ordered. And 16% chose C, and you know that's gonna be what happens. They take their first number, their last number, and they're like, "Oh, my teacher said we subtract 34 minus 16." Look at that, it's right there. And we had 16% of our students choose that. Unfortunately, 16 is not the lowest number, and 34 is not the highest number. It's not first minus last, it's highest minus lowest. And so we need to make sure that they know that they're always going to get the data set in a mixed up order. So when we're using numerical summaries, let's use these these terms like measures of center, mean and median, measures of spread like range and IQR, right? Classify these different calculations. And then if they understand why these measures are beneficial, so we look at some real world scenarios or information rather than just random calculations, it might mean something more to students if they know why we would want to find the measures of spread or the measures of center. What do we use these for? 6.4b is next. This is applying quantitative and qualitative reasoning to predict and compare real world ratios and rates. All right, so for number 6, we've got a ratio of green to blue is 7 to 13. The floor is a total of 3,000. How many is blue? All right, so there's a hidden number here. So I'm going to say blue and green. So I need my green first. Green is 7. Blue is 13. But what's missing is my total. If I've got 7 of one, 13 of the other, that means I've got, out of a total of 20, 7 are green, 13 are blue. I'm going to need that because look at this floor, it has a total of 3,000. So if I'm going to set up my proportion, I need to know that there are 13 blue over 20 total, and that's going to equal my unknown number of blue with my 3,000 total. And I can do cross multiplication. I can do some basic simplification if I want to. Let's go ahead and just cross multiply. You can also try to figure out 20 times what gets you 3,000. So 3,000 times 13, it's going to get 9. And let's get 1, 2, 3, 3. Okay, so that's going to be 39,000. And then I need to divide that by 20. Okay, so I'm going to take my 39,000, divide that by 20, right? And that's going to go in once. And then that's going to go in 9 times. I got 100. That's going to go in 5 times. And then I need that extra 0. So 1950. 1,950. 45% of our students were able to get that. On this one, we've got an hourly rate, but they don't tell us what the hourly rate is. They tell us how much Leanna charges if there's 3 hours, 4.5, 5, 9. So there's two ways to solve this. If you want, you can find that unit rate and then multiply that by 9. So let's do that. Let's do 3 hours for 67.50. So let's just divide that. Let's figure out how much 1 hour costs. 2, and that's 2 again. We're going to ignore that decimal. That's 5. Got to bring out this last 0. All right, 22.50. All right, so 1 hour equals 22.50. So 9 hours is going to be 22.5 times 9. 45, that's 1822. 1820, one digit behind the decimal, 202.50. Another way to solve this would think, well, what's the relationship between, look, if I double 4.5, 4.5 times 2 equals 9. So let's just double 101. I can either multiply by 2 or I can just add twice. So if we see these relationships, we could have made this a lot easier. We would have gotten that same thing, 2250 or 20250. And so in number 6, we had to find that total 20, even though it was not given in the proportion because it was asking for that total of 20, even though they only gave us the 7 and the 13. And then 28% chose D. So 28% chose D. How did we get that? Well, we multiplied this 7/13 by 3,000. Now, that doesn't sound like fun, but they just did like this, 7, 13, and we're going to multiply this by 3,000. And you're going to end up getting that 1615, which, it looks big. We know there's going to be a lot of tiles. Like I understand not choosing B and C, but this is how we chose D, and obviously they didn't set that up correctly. But number 25 is more straightforward. We had to find a user rate, or we can just like I did, double that 101.25. We could have used reasonableness to eliminated 2 answer choices, right? So if we were to go back here and say, well, even if I didn't want to do that 4.5, right? This 5, if I double that, it's going to be 10. So that's going to be slightly more. So if I double that, this can be like 224. So it's going to be slightly less than that. So it would have been these two that I would have been looking at, and these two are going to be much too far away. So I could have at least eliminated A and C just by reasonableness. So instead of having students memorize one way to solve these problems, you notice I solved each of these problems at least 2 different ways. We need to model flexible approaches because honestly, on number 25, it was a lot easier for me just to double the 101.25, but I needed to recognize that. And so we need to provide our students multiple opportunities so they understand how they can solve these with a variety of strategies and techniques. Next, we're looking at summarizing or interpreting numeric data here, summarizing dot plots, stem and leaf plots. In this case, we're looking at histograms. And so we have a histogram which is going to act like a bar graph, except that each bar has a range of data. So I suggest that we, like we would with a bar graph, go ahead and label each of these. So the 0 to 49 range is going to have 15. 15 to 99 has got 30. We've got 100 to 149 that's got 35. The highest is 50, 150 to 199, and then 30 again for over 200. Then I suggest we evaluate each of these statements, but we do it algebraically here. So the number of students or the number of customers who drove 150 miles or more. All right, so that's going to be 2 buckets right here. That's going to be 50 plus 30 is the same as, all right, so that's equals the number of customers who drove less than 150. All right, so less than 150 is going to be right here. And so I've got 15 plus 30 plus 35. All right, so 50 and 30 make 80. 15 and 35 make 50. At that 30, we've got 80. All right, so 80 looks like it is equal to 80. So I'm thinking my answer is A. But as always, we need to verify the other 3 are incorrect first. So more customers drove 50 miles than any other distance. Well, first off, I can't evaluate this because I have no idea how many drove 50 miles. I know that there are 30 people that drove 50 to 99, but of those 30, I don't know how many drove exactly 50. Same thing with D. More customers drove 30. I don't know how many people drove 30. I don't know how many people drove 50. The 30 is sitting in between the 0 to 49, but I literally could have 0 people driving 50 miles. All 30 of them could have been 51 to 99, right? I could have had 15 people all driving 6 miles and would have sit within this range, and none of them would have drawn 30. So you can't really evaluate B and D. We can evaluate C. The number of customers who drove 50 to 99 miles, all right, so that's 30, is less than the number of customers who drove 200 miles or more. Nope, 30 is not less than 30. 30 is equal to 30. So our answer here is A. Only 55% of our students were able to get that correct. We had to evaluate each statement separately. Now, 27% chose C. Let's look at that one. Why we think that might be so enticing. If we weren't looking at the values, if we were just looking at the numbers, 50 is less than 200, 99 is less than 200, then wouldn't the 50 to 99 be less than 200? Well, actually, no, it's not. But if you evaluate just the numbers that separate that bar or that category, rather than how many people are in that bar or category, you can kind of see where students might have gotten confused on that one. We need to turn each sentence, like I did for you, into an expression, into an equation, perhaps an inequality, in this case, an inequality, sometimes, or sometimes an equation. That's how we evaluate these statements. And that should be the first thing that students do is put numbers on these statements and then evaluate whether they are true or false. Next, 6.3D, we are using all four operations: add, subtract, multiply, and divide. As you can tell, we had little problem with number 2. We need to take each number here and basically find the total. So we're just adding. So one method to do this is let's just add the positives: 2, 8, and 3. Okay, so that's going to be 10, 13. And let's take our negatives: -6, -5, -1, -6. Let's figure out how much that is. So 5 and 1 make 6. So basically 6, 6, and 6, that's 18. So I've got 13 minus 18. That's going to be -5. 75% of our students were able to get that. That was not the challenge. The challenge was number 24. And we're not dealing with any exponents, so we just have some parentheses, right? We do need to use our order of operations here, even though this is the SE that deals with just adding, subtracting, multiplying, and dividing. We need to be able to do it within the order of operations that we start in 5th grade and then really solidify in 6th grade, right? So we're going to deal with this parentheses first. So 2 minus 5 is -3. And then let's just recopy everything down, because what we obviously add in 6th grade are negative values. Everything is positive when we first deal with this in 5th grade. So what do I have left? Well, I've got, first off, we need to know that when we have a number outside of a parentheses, that means we're multiplying there, we're multiplying here. So I have 3 operations. I've got 2 multiplications and an addition. So let's take care of the multiplications first. So -8 times -3. All right, 2 negatives make a positive, so that's going to be 24. I'm going to keep that add. I don't want that to deal with that yet. And then I've got a 3 times -4, so a positive and a negative make a negative, so I'm going to do like this. 24 plus -12, you can rewrite that if you want to visualize it differently as 24 minus 12. So therefore, our answer is simply 12. Only 35% of our students got that right. Now, we had to use these order of operations. I listed them here, 5.4F and 6.7A. If you didn't have the order of operations, you were not going to be able to solve 6.3D. So we cannot teach these skills in isolation. Now, the answer choices for number 24. Take a look at this. 25% chose A, 27% chose D. So let's look at that. So 25, 27. Our correct answer is 35. That's a lot of guessing. When you're getting some answer choices, more than one, that are getting close to that 25%, that means that we just had a lot of kids not even try. They just kind of tapped out on that one. And so that is something that we need to be focusing on because that wasn't an inaccessible problem. That should have been a problem that our students did very well in. And honestly, the 6th graders this year did very well with 5.4F the previous year in 5th grade. So that was kind of a surprising result. So if they wanted to get A, what they did is they multiplied that 8 and -8 and the 2 first, right? So students that got A just literally went from left to right. They ignored the parentheses. Well, they kept the parentheses, but they kind of ignored the order of operations and they would just go from left to right. And if they got D, they subtracted the 2 minus 5, and then added the 3 to get 0. So they did this those that chose D, but then they just ignored that and they kept going over here, and that's how they ended up with that -12. So there's ways to get to these right here. So we need to use order of operations fluidly with all four operations. As we've said throughout this video, when we use division, let's make sure that we are using fractional notation like this. We need to include exponents because those are a thing. And we need to include two levels of grouping, right? Let's make sure we use our brackets, including our parentheses. And basically from now on, the way that we need to show multiplication, even if we're just doing basic multiplication, let's just do 3 times 8. Let's start showing it like that. Because if we can get away from this, and especially away from this, which becomes confusing when we start using x's as variables, if we can get into this notation, this is going to set them up because this is basically how we're going to show multiplication moving forward, and they need to get used to that. Finally, 6.6c, 58%. We had a drag and drop here. This is a 2-point problem. We needed to represent equations and situations, tables, graphs. All right. So let's take a look at this first one on the left, this table. So we are getting smaller. We're looking at the x and the y. So we are getting smaller. So 8, I'm going to bring this over here. 8 goes to 2. How can I get from 8 to 2? Well, I can subtract 8 minus 6 equals 2. Or I can divide. 8 divided by 4 equals 2. So now I've got two different possibilities, a minus 6 or divided by 4. So let's try that with the next one, 12. So 12 minus 6 equals 6, which I need 3, so that's not going to work. 12 divided by 4 equals 3, that works. 16 divided by 4 equals 4, that works. 24 divided by 6 equals 4, that works. Okay. Or divided by 4, excuse me, equals 6. Okay. So I need, the rule here is divide by 4, but how do I show divide by 4? Well, this is something that we've talked about. We can divide by 4 by this. We can divide by 4 like this. We could also multiply by 1/4, right? You can divide by a number and multiply by its reciprocal and get the exact same answer. So I see this right here, but take a look at this. They flip the x and the y. We are not dividing by 4 or multiplying by 1/4 the y. We are dividing by 4 or multiplying by 1/4 the x to get to the y, so we don't need this one. What we need is, and here we go, this is how we show division in 6th grade, x over 4. So that's going to be big here. It's showing division in fractional notation there. Now let's take a look at this, and I want to do the same thing here for this one, but let's just create a table of values to make it easy. All right, so I'm going to do this with blue, and if we could do our table of values, we can evaluate it pretty easily. All right, so 0, 0 is my first one. 1, 2, 2, 4, and then I've got what, 3, 6. Okay. Well, I can't really do anything with that 0 simply because if we multiply anything by 0, we're going to get 0. But that does let me know this is going to be multiplicative because I can add and get off of 0, but I can't multiply and get off of 0. So let's look at multiplication, right? What can I get? What can I do to 1 to get up to 2? Well, I can multiply by 2. So I can multiply by 2, can multiply by 2. See, if I were to try addition, I would need to do a plus 0, and plus 0 obviously falls apart real quick. All right, so this is going to be a times 2. So how could I do times 2? And we're going to see it right here. Y equals 2x, right? And we just put the number in front of the letter. Lack of operation there shows that we are going to multiply. All right, so those are our two answers. As you can see, 43% got full credit, 29% got partial credit. If we take that partial credit, add it to the full credit, that's where we get our 58%. All right, so we needed to show this relationship in the table of values, and you see it right here. There's three different ways that we could represent that divide by 4. Our students need to be comfortable with all three. Now, this is the first time that 6.6c, this particular item, has asked students to evaluate both a table of values and a graph. Usually, it's one or the other, and it's either going to be, multiplicative or additive. But in this case, they both happen to be multiplicative, and one was a table, one was a graph. So students need to be comfortable moving back and forth between those two. And we need to just move interchangeably between table of values, graphs. That's how I solved the graph, was by creating a table of values. We had to generate equations for both the table of values and the graph. So those three showed up here. We didn't have it in this problem, but sometimes it's going to be a verbal description. It's going to be a word problem about someone going to the store and buying oranges for so much cents per orange. They need to be very comfortable moving between all four representations here. And as I had to first evaluate, is this an additive or multiplicative relationship, we need to provide our students those opportunities and possibly some steps and tools so they can decide whether the relationship is additive or multiplicative.